Our video here for 4:30 is brought to us by this Star Wars droid. Okay, so we've collected our sample from our population, and from that sample we've collected our data, or we've generated our sample using some sort of random process. And that from our sample, our individuals in our sample, we've got our, let's call it raw data, or our data. And we're going to do some work with that data. And one of the things we do is organize it. We already mentioned earlier in the video, there's categorical data and quantitative data. Here's some examples, an example of categorical data. This is the blood type of 25 volunteers in some sort of medical research. And the categories make sense to use what? A, B, and O as our categories, because those are the 4 types of blood types that are listed here. And what we want to know is how many of each blood type did we collect? That's called the frequency. And we're talking about, we call this a categorical frequency distribution, because we're saying what is the distribution, or how many of each type showed up. Now, in reality, we're going to do this by hand, but in reality, we've got robots, we've got software that would do this for us. Our author uses a tally marks thing here. I don't ever bother with this because I'll show you, when I count, I just cross it off in the table, and that's how I'm counting, or that's how I'm making my tally marks. So for A, I'm saying here's 1, 2, 3, 4, 5. I've got 5 individuals that had blood type A. For B, I've got 1, 2, 3, 4, 5, 6, 7. For AB, I've got 1, 2, 3, 4. And then for O, it's all that remain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can do a check, just like we did back with probabilities. We can calculate the sum of all these. If this adds up to 25, like we were told up here, then we've done our count correctly. So 5 plus 4 is 9, plus 9 is 18, plus 7 is 25. Okay, we've accounted for all of them. This gives us our categorical frequency distribution, and we can calculate empirical probabilities from this. For example, we could say, what's the probability of a randomly selective individual from this sample having type A blood? It's 5 out of 25. What we then might say, if this represents the population of volunteers for medical research studies, we could say that at any given time when we do a medical research study, we can expect a 5 out of 25 chance that we're going to have a type A blood person volunteer, or a 9 out of 25 chance that a type O blood person would show up. So what we then might want to ask ourselves is, well, is this really a good sample, a representative sample of a population? And I'm going to say no, because there's no randomness involved in the sample collection. Individuals volunteered for this study. So it would not represent any sort of population. Okay, well, what about quantitative data? So if we have some numbers, we can create what's called a grouped frequency distribution. And sometimes we do this when we have a really big data set with tons and tons of numbers, and those values could be any number in a given range of values. For example, if we took the weight of an individual, and our author points out that no 2 people are going to weigh exactly the same amount. That likelihood is pretty small, especially depending upon how accurate we're wanting to be with their weight. If we're rounding everyone's weight to the nearest pound, then there's a good chance they would weigh the exact same amount. But if we're rounding to the nearest 1/10 of a pound or 100th of a pound, it's going to be pretty rare that we'd have people weigh the same amount. So we create what's called classes of weights. And this shows up like in wrestling and in boxing. You have different you pit wrestlers against each other that weigh roughly the same amount so that it's a, quotes, fair fight. So we're grouping people into ranges of, say, like a 20-pound range. That's what these limits are. And what we do is we create a lower limit and an upper limit. And we can separate them like this as one way to show it. And the way this one is showing is the lower limit is 100, the next lower limit is 120, and we're saying the upper limit for this first class, we could even label them as classes here. Class 1 went from 100 to 119. Class 2 is going from 120 to 139. Class 3 would go from, let's see, 140 to 159, and so on and so forth. And then what we would do is count how many people fell into each of these categories when we collected our data set. So we'd count the frequency. Now our author asks a pretty good question. Where would we put the 119.8 pound person? Well, they would go into this class, because what we're really saying is this class represents someone who weighs 100 up to 120, but not including 120. When they hit the 120 mark, they fall into the second class, and anyone would go into this class up to 140. If you're familiar with algebra notation, we would write this as 100 up to, we're inclusive of 100 up to 120 with a parenthesis, so we put a bracket on that. This shows we get infinitely close to 120, but not equal to 120. Okay, so how do we create a grouped frequency distribution? Well, here's our steps. First, we need to make a decision about how do we want to break apart our data set? How many classes do we want? So when you first are handed a set of data, it's already broken into, quotes, classes. Each individual data value is its own class. So you want to think about when you group it, are you going to get any information by this grouping? So if you end up with 15 classes, you should probably have thousands of data values in your data set, so that when you group it, you've got something interesting to look at. You've got pretty high frequencies in each class. If you have smaller data sets, you want probably less classes. Then you want to decide how far apart is each class. So we have a little formula for that, what we call the class width. What you do is you take the largest data value, also known as the maximum, you subtract from it the minimum, and then you divide by however many classes you've picked. This gets you how far apart you want each of the data values, or each of the classes. So if you look here, this width was 20 units between each. So the distance between these two was 20. Had we taken the largest value minus the smallest value divided by the number of classes, we would have gotten 20 in this formula, and that's how we would have built this. Notice we're always going to round up. So if we'd gotten, say, 19.1376, we would have made this a 20. Then we'll have a beginning lower limit as a nice starting place. We would add this width until we have the number of classes, find the upper limits, and then count. So I'm going to demonstrate this using this data set on the next page, and I'm going to do this in Excel to make it easier. But first, let's talk about what the data set is. These are the record high temperatures for the 50 states. So in Alabama, the record high was 112 degrees Fahrenheit. Now the author says, why would a categorical frequency distribution be a bad idea? Because it already is a categorical frequency, right? The categories are the states. So it doesn't group the data in any meaningful way. It doesn't tell us anything or help us learn anything about the data set. So instead, we're going to do what this example suggests and build a grouped frequency distribution. All right, so here goes Excel. What I have done is taken all those data values and put them into Excel. So here they are. And the first thing we want to do is turn this into the smallest number to the largest number. So I'm sorting it from smallest to largest. Note the minimum was 100, and the maximum was 134. So if I want to calculate the width, all right, let's make this, what would I make this whole thing 24? If I want to calculate the width, I want to do the largest number, which is 134, minus the smallest number, and then we need to decide how many classes are we going to use. Well, in his example, he chose 7 classes, so we're going to divide by 7. Notice our number is 4.85777, so we're going to make our actual class width 5, meaning the distance between the lower limits is going to be 5 units. So we'll go over here and I'll make our first, I'll make 2 things. We'll say our lower limit will be our first column. And then the second column will be our upper limit. If I could type. Good gracious. And then I'm going to do frequency. I don't know if you know this trick, double clicking in between. I want this to be limit. I want this one to be frequency. There we go. Okay. So we're going to pick a nice number for our lower limit. That's going to be 100. It has to either be the smallest number or something a little bit smaller. Then I'm going to add 5 to this because that's our width. So I'm going to take this number and do plus 5. And I need a total of 7 of these. So over here, I'll write out, here's my classes, and there's my lower limits. So my upper limits then will be 1 minus this 105. So what I'll do is I'll select it, and I'll say minus 1, and there we go. Our upper limit is 104. And oh no, the last one doesn't make any sense, so I'm going to make another fake lower limit of 135, and that gets me what would be my upper limit for my very last class. Now all we have to do is go back to our data set and count how many numbers are between 100 and 104. I select this. It's really hard to see, but there's a number right down here that says count. I'm seeing that there are 3 here. Then I need to go from 105 to 109. I'm selecting all of those. Down here I see there's a count of 8. Then I'm going to select 110 to 114. Escape. So 110 to 114. Why is this doing this? What happened here? Okay, so 110 to 114. 110 to 114. There I'm seeing 16. Then I need 115 to 119. I'm going here and I'm counting all the way up to 119. I'm seeing that count is 13. And then I need 120 to 124. 120 to 124, and I'm seeing a count of 7. And then I think these last 2 I can just type in pretty easily. 125 to 129. There's 2 and then 1. Now we can check that we did this right by adding them up. So we can calculate the sum of this. This should be 50. If we don't have 50, then we did something wrong. Oh, good news. We did it right. We've generated the grouped frequency distribution for this data set of high temperatures. And what this is showing us is that the majority of our data values or our high temperatures for these states fall between 110 and 119, right? We've got 29 states falling in that high temperature. So, I mean, we could argue about whether or not that's super useful information, but that's the idea of what a grouped frequency distribution shows us.